Namaskar. Welcome to the session on processing of the market milk. Milk is one of the most precious natural materials and has been a basic component of human food for a long time. It is one of the oldest foods and at the same time the most important one. The milk obtained from cow or buffalo, when presented in the form that can be saleable, is termed as market milk. The milk obtained from the animal is termed as raw milk. The milk that undergoes various stages of processing before it reaches the consumer in the form of liquid milk. This episode deals with market milk under the following subheadings: collection of milk, reception, platform testing, stages of milk processing, filtration, homogenization, pasteurization, description and working, clarifier, cream separator, homogenizer and plate heat exchange. Collection of milk. Milk is the most perishable food which needs to be collected and stored in chilled conditions, that is below 5 degrees Celsius, to retain its original quality for a longer period. In India, milk is collected in cooperative system which works on 3-tier system, that is society, union and federation. The collection centers at villages forms the societies. The milk unisons in a geographical state forms federation. That is, the societies are controlled by unions and they are monitored by the federation. The society is formed at village level where the farmers can give the milk to the society. The milk is collected from the farmers and the quantity is measured. A sample of milk is taken out for testing the quality of milk for its fat and solids, not fat, that is SNF content. The payment is made to the farmer based on the fat and SNF content of the milk that he or she has given to the society. The milk is collected twice a day, that is in the morning and in the evening. Milk is collected from the societies and transported to the chilling center for chilling of milk, where it is further processed. Thus, milk reaches the chilling center within few hours of milking. At the chilling center or milk processing center, the milk is tested for its organoleptic qualities and platform tests are conducted to check the presence of adulterants and other preservatives. The detection of adulterants and preservatives are done by simple and instant chemical tests which qualitatively show the absence or presence of the additives. The common additives that are tested are sugar, starch and urea, while the common preservatives those are tested are sodium bicarbonate and hydrogen peroxide. Organoleptic tests. The milk which is free from dust and other materials is smelled to judge its freshness. Doubtful milk from the can is taken into a test tube about 5 ml and heated over a flame to boil. If any flakes are seen in the boiled milk, the milk is said to be positive for clot on boiling, that is COB test. This indicates that the milk is old and has become sour and unfit for processing. Such milk can be rejected for processing. Milk is tested chemically for the presence of neutralizer to confirm its presence. Similarly, milk is tested for presence of any additives like starch, sugar, urea or any other additives. The milk containing additives and neutralizers will be rejected for processing. Now next is the stages of milk processing. Filtration. The milk after organoleptic and platform tests is filtered through muslin cloth and online filters to remove all visible extraneous matter present in raw milk. To remove the invisible extraneous particles, clarifiers are used which works on the centrifugal force. The design and principle of operation of clarifier is similar to the cream separator, which is explained later. The main difference between clarifier and cream separator are the clarifier will have only one outlet for clarified milk, while the cream separator will have 2 outlets, one for cream and another for skim milk. The clarifier work at lower RPM compared to cream separators, and the separating discs are smaller in clarifier to house more amount of sludge. Chilling. After receiving the milk, It is filtered using filter cloth and is immediately chilled to less than 5 degrees Celsius. The microorganisms grow well at room temperature and bring about undesirable changes in milk and also make the milk sour within a short period of 2 to 3 hours. The chilling of milk to less than 5 degrees Celsius controls the growth of microorganism and thus helps in retaining the freshness of milk for longer period, that is more than 18 to 20 hours. There are various methods of chilling the milk. For small quantities, the bulk milk coolers and can coolers are used. In bulk milk coolers, the fresh raw milk is poured into a double jacketed vat and the refrigerant or chilled water is circulated between the jackets and the milk is kept agitated at very low RPM till the temperature of the raw milk reaches below 5 degrees Celsius. The milk is chilled to less than 5 degrees Celsius in about an hour. This type of cooler is used when the quantity of milk chilled is about 5,000 liters. If the quantity of milk to be chilled is about 1000 liters, generally can coolers is suggested. In this type of coolers, the cans with milk is immersed in chilled water tanks where the chilled water temperature is maintained at less than 4 degrees Celsius. For more than 5,000 liters, plate heat exchangers are used. In plate heat exchangers, the milk is instantly chilled to desired temperature. After chilling, the milk is pumped into insulated storage tanks. The milk is then standardized to desired fat and milk solids not fat, that is SNF levels, to the legal standards before it is pasteurized. The legal standard for market milk is given in table 1. First column is about the type of milk, second column deals with the milk percentage, next is the percentage of fat in milk and finally the SNF. Skim milk, maximum 0.5, minimum 8.7. Double tone milk, minimum 1.5, minimum 9.0. Toned milk, minimum 3.0, minimum 8.5. Recombined milk, minimum 3.0, minimum 8.5. Standardized milk, minimum 4.5, minimum 8.5. Cow milk, minimum 3.5 and minimum 8.5 in Karnataka. Buffalo milk, minimum 5.5 and minimum 9.0 in Karnataka. The fat in milk is reduced to desired level by separation of milk. The storage tank capacities varies from 10,000 liters to 150,000 liters. The storage tanks are equipped with thermometer, agitator, manhole for cleaning the tanks manually and view glass to know the volume of the milk stored. Standardization of milk. The representative sample of the milk from the storage tank is taken and the fat and SNF content is estimated. Then, fat and SNF content in the milk is adjusted to desired level by using Pearson square method. The fat and SNF is adjusted to supply uniform quality of milk to the consumers throughout the year and mainly to meet the legal standards. Plate heat exchangers. A popular heat exchanger for fluid of low viscosity such as milk is the plate heat exchanger, where heating or cooling fluids flow through passages between alternate plates while the milk to be heated or chilled flow through the remaining passages of alternate plates. The heating or cooling medium and the milk are pumped in opposite directions for efficient heat transfer. The PHEs are generally used in chilling units and continuous type pasteurizers, that is high temperature short time pasteurizers. The main advantages of PHEs are high energy efficient, occupies less space, compact and simple, easily cleanable by cleaning in place system, capacity can be increased by addition of plates and hygiene and sanitary method of processing. The gaps between the plates are packed with gaskets to avoid leakage of the milk and the heating or cooling medium. The plates are corrugated to increase the surface area for heat exchanger and provide turbulent flow of the milk. The turbulent motion of milk helps in bringing every particle of milk to the surface so that they are instantly heated or chilled. The diagram of pHe and flow of milk and the heating or cooling medium is shown in figure 1. Cream separation. The raw milk that is received from villages will have varied percentage of fat and SNF. The fat content of the milk has to be at standard level as per the legal standards in table 1. The excess fat present in the milk has to be removed. The fat is removed instantly from the milk by using cream separator. The cream separator works on the principle of centrifugal force. Centrifugation may be defined as a unit operation involving the separation of immiscible materials by the application of centrifugal force. The difference in density of fat 0.930 and skim milk, that is milk without fat content, which is 1.030, is taken into advantage for separating these two components of milk. In a centrifugal separator, milk is separated in disc-type centrifugal machines that employ force from 5 to 10,000 times that of gravity. The cream separator has two main parts, that is separating bowl and driving mechanism, which make the bowl to rotate at a fixed speed, which may vary from 5,000 to 10,000 rpm. The design of the centrifugal cream separator is shown in figure 2 and figure 3. The milk will enter the interior of the bowl from the central tube to the bottom of the rotating bowl into the distributor. Under the influence of the centrifugal force, the lighter fat globules travel inwards towards the axis of the centrifugal center of the rotation, and the heavy phase, that is skim milk, moves outwards towards the wall of the bowl. The fat along with a small portion of milk called cream is collected through the cream outlet. Similarly, the milk without fat called skim milk from the gap of the disc is collected at the end of the disc, moves upwards, and above the top disc are collected from another outlet called skim milk outlet. Thus, the flow of cream and skim milk is separated by the neck of the top disc. All the fat that is present in raw milk is separated into cream, and the skim milk will have only traces of the fat that escapes the centrifugal force during separation. The maximum fat content in well-operated cream separator will be less than 0.1%. The cream separator is said to be efficient when the fat content in the skim milk is less than 0.05%. Conditions for separating milk are: the temperature of milk should be between 35 to 40 degrees Celsius. The flow of milk into the bowl should be uniform. The flow should be smooth and there should not be any vibration during operation. The cream separator should be switched on at least 4 to 5 minutes before. Feeding the milk into the bowl to attain some maximum speed of bowl rotation. Pasteurization. Pasteurization is the process of heating milk to a specific temperature for a specific period and immediately chilling to less than 5 degrees Celsius so as to make the milk safe for consumption. The primary purpose of pasteurization is to kill all the microorganisms capable of causing diseases. The Mycobacterium tuberculosis is taken as indicator pathogenic bacteria for checking the efficiency of the pasteurization, since it is the most resistant pathogen that is likely to present in the raw milk. The time-temperature combination for pasteurization of milk is fixed on the destruction of Mycobacterium tuberculosis and Coxella brunetti. These pathogenic bacteria are destroyed at temperature combination of 60 degrees Celsius for 15 minutes or 70 degrees Celsius for 12 to 13 seconds. There are two types of pasteurization. First is the holding method, low temperature and long time, that is LT-LT type, wherein milk is heated to 63 degrees Celsius for 30 minutes. Next is the continuous method, high temperature short time, that is HTST type, wherein milk is heated to 72 degrees Celsius for 15 seconds. Holding method. In this method, the milk is heated or cooled in batches. The milk is taken in double jacketed vat and the milk is heated to 63 to 65 degrees Celsius by circulating hot water in the jacket and held at that temperature for 30 minutes. The milk is finally cooled to 5 degrees Celsius by circulating chilled water in the jacket. In some vats, the heating and cooling of milk is done by using PHEs, which is more efficient than circulating method. The batch type pasteurizer is shown in figure 4. Next is the continuous method. This type of pasteurization involves high temperature short time, that is HTST process, in which the milk is heated to a minimum temperature of 72 degrees Celsius with a holding period of just 16 seconds before it is cooled to less than 5 degrees Celsius. The raw milk first enters a balance provided with the float valve, which controls the flow of milk into the pasteurizing unit. A centrifugal milk pump pumps the milk into the regeneration section, PHE, where the chilled raw milk passes in alternate gaps in the PHE. Then, the milk enters the final heating section where the milk is heated to final temperature of 72 degrees Celsius. After heating, the milk passes through a holding tube where the milk is held at the temperature for 16 seconds. The length of the holding tube is such that the hot milk takes 16 seconds to travel through the tube. At the end of the tube, a unit is fixed which is called flow diversion valve, FDV, which diverts the milk back to the float balance tank if the milk temperature is below 72 degrees Celsius. If the milk temperature is above 72 degrees Celsius, then milk is allowed to flow forward to the regeneration section where the chilled raw milk is flowing alternate gaps of the PHE. Here, the outgoing hot milk is cooled to around 50 degrees Celsius by the chilled milk, which is flowing in alternate gaps. The chilled milk, which is heated to around 55 degrees Celsius before the raw milk enters the final heating section. The partially cooled pasteurized milk then enters into another PHE where the milk is cooled to room temperature by using tap water in the PHE. Finally, the milk enters the chilled section of PHE where the milk is cooled to less than 5 degrees Celsius. The flow of milk in HTST pasteurizer is shown in figure 5 and 6. The advantages of batch type pasteurizers. They are convenient for low volume handling of milk, low investment, easy to clean and can be handled by semi-skilled personnel. The disadvantages. They are not hygienic in operation, chances for post-processing contamination, low energy efficient, not suitable for high volume milk processing, more time consuming and occupies large floor area. The batch type pasteurizers cannot be synchronized with other operations such as online cream separation and homogenization. To check the efficiency of desired heat treatment given to milk, the presence of enzyme alkaline phosphatase is tested. This enzyme gets inactivated at the temperature just below the pasteurization temperature. Hence, if the phosphatase test answers positive, it indicates that the milk has not attained the temperature required for destruction of this enzyme, which in turn indicates the incomplete destruction of the pathogen and inefficient pasteurization. After pasteurization, milk should be immediately chilled to less than 5 degrees Celsius. Homogenization. Homogenization is the process of breaking the fat globules so that the fat does not separate during storage at cold temperature. The size of fat globules in milk ranges from 2 to 20 microns. The bigger fat globules have the tendency to rise to the top when kept undisturbed. During homogenization, the bigger fat globules breaks down to small size of less than 2 micron, so they do not raise to the surface during storage. Before homogenization, it is mandatory to heat the milk to at least 60 degrees Celsius to bring all the fat into liquid phase and mainly to inactivate the native lipase enzyme, which otherwise hydrolyzes the fat and results in off-flavor development in milk. The milk is homogenized in two-stage homogenizer. In first stage, the milk is homogenized at 2500 pressures per square inch pressure and second stage at 500 pressure per square inch. This is because after first stage of homogenization, the broken fat globules have the tendency to clump together to form loose cluster similar to grape cluster. In second stage, these clusters are disintegrated to distribute the broken fat globules uniformly in the milk matrix. The principle of homogenization of milk is shown in figure 7. Now next coming to packaging of milk. The pasteurized milk is generally packed in polyethylene pouches in 500 ml and 1 liter capacity. They are filled in form fill seal machines wherein the roll of polyethylene film is fed into the machine. The machine will form the pouch, fill the pouch with preset volume of liquid, that is milk, and seals and cuts the pouch after filling from the next pouch. The packed milk is collected in plastic crates and stacked in cold store till it is dispatched for distribution. Flow diagram 1. Flowchart for milk processing. Reception of milk at reception dock. Platform test for accepting or rejecting milk, that is clot on boiling test, neutralizer test and adulterants test. Filtration of milk to remove dust, weighing of milk, chilling less than 5 degrees Celsius, stirring in insulated tanks, standardization of milk to desired fat and SNF level, forewarming to around 60 degrees Celsius, homogenization. Two-stage at 2500 pressure per square inch and 500 pressure per square inch, followed by pasteurization, that is HT-ST at 72 degrees Celsius for 15 seconds, LT-LT at 63 degrees Celsius for 30 minutes, followed by chilling to about 5 degrees Celsius, storage in insulated pasteurized milk tank, and then packaging, storage in cold storage at 5 degrees Celsius, and finally distribution. Flow diagram 2. Flow of milk in HT-ST pasteurizer, raw chilled milk, float controlled balance tank, regeneration section, final heating section, holding tube, flow diversion valve, regeneration section, cooling section, chilling section, pasteurized milk tank, packing, cold room maintained at 5 degrees Celsius, followed by distribution. Conclusion. Milk is one of the most nutritious and essential commodity. Most of the Indian population, being vegetarian, depend on milk and milk-based products on daily basis. Milk processing plays crucial role in the shelf life of the milk. Milk has to be standardized as per the FSSAI standards before marketed based on the type of milk. Pasteurization and homogenization of the milk is important to ensure the quality of milk during storage and till it reaches to the consumer.